Morning, everybody. Welcome back on the rainy Monday. Let's see, let's do a check-in and see how everybody's doing. Raise your hand if over the weekend you're able to review the slides and you feel 100% solid on everything up until now. Okay, that's maybe a third. Raise your hand if you are 80% there. Cool. Okay, and that's a good chunk. And then don't be shy. Raise your hand if you need me to slow down or think it's a new language and it's a little tough. Okay, thank you. So hopefully the homework will be a second round of reinforcement for everybody. And for those of you that 100%, don't forget those challenge questions. I do think they're an additional opportunity to really be warm to the more complicated topics when they come up later. And I will try to be around a little early before class, not just before class because I got to set up, but just before class. So if you catch me around 8:45, I'll be happy to help out with stuff. I'll try to hang around, and I'm always after, immediately after we finish, just before lunch, I'm around. Okay, so then big picture, where we're at is we have one topic left from the last class, so that'll be a sort of a mild warm-up for us. We'll look at functions, because I want everyone to be solid on what a function is. It's a foundational aspect. And then today's topic will be Dplyr, which is a grammar of manipulating data. It's a nice sized topic. It's very identifiable, so you can dive into it. And what I meant is encapsulate. It's an encapsulated topic, so we can get it, they can drill it, it's nice and understandable, and you have plenty of room. Tomorrow is ggplot, which is also a nicely circumscribed, defined subtopic, but it takes more work. So that one will open up an avenue which you can explore and really dive into, or not, because it's optional. Understanding of analytics don't depend on ggplot, but you do want to know it. It's a cool thing. So that will be a bigger topic. And then that will be what you get from me for this week. And then the next time that I will be teaching you guys will be the Monday after for foundations of statistics. And for that, you definitely want to be ramping up on your basic probability theory. Maybe I'll send you guys some YouTube links of recommended. I think the school already does that. I think I picked some of them out from the school. So I might be sending you what I happened to already picked a year ago. But nonetheless, I'll send that to you so you guys can warm up. You'll want to be warm with probability theory. I did put up the slides, but the slides are a little bit basic. So we'll be radiating off the slides to try to build into the details. So the slides start at the very beginning with defining mean and standard deviation. But I don't want you to look at that and think, it's just mean and standard deviation. It'll go a good bit beyond that into hypothesis testing and deriving distributions from each other. So that's the challenge that's coming a week ahead. But for now, let's dive in. We'll finish functions, and then we'll move on to Dplyr. So for today's class, we have the slides. I'll go to them. Week 2. Well, first you have yesterday's slides. So that was at week 1, and Intro to R Part 2. And you can bring up to your computer these slides from the previous class. And for this class, under week 2, we have manipulating data with Dplyr. And you'll have 2 data sets that you'll want to use, births and b names. You can take a moment now and download them and put them in the working directory that you're using for R, so you'll have access to them. And of course, the slides are right here. And now, before that, just finishing off our last class with functions. So we have here a basic outline of a function. You'll have the name equal to the function and the parameters that are passed to it. It says arguments. I tend to say parameters, so I'm going to stay with that terminology. I think it's a fairly standard terminology to say you pass parameters to a function. Certainly when you start talking in terms of statistics, you tend to say parameters. And then the output of your function is returned. So you use the return command to send it out. Sometimes the very last value of the function is sent by default. So some functions will not have a return statement, and you may wonder what's happening. That's just being informal and allowing the very last term to be what's passed back. Yes? The parameters to a function. And so in statistics, let's say the normal distribution has parameters mu and sigma. And then log normal has parameters also mu and sigma. So in statistics, you tend to use the word parameters more often, although you could say that to the function, if you treat distribution as a function, you could say they're arguments. Anyway, I'm just saying here that for functions, I will be using the word parameters instead of arguments because it's consistent with statistics and it's just as appropriate. Okay, so here is our first example. I recommend you type this out. It'll keep you active and you can feel it. So we have a function called calculate area, calc area, and we type out function to create this. We decide on our parameter to it, which is going to be r in this case, and then we open a bracket to define our function inside the brackets, and inside it we define a variable called area equal to pi times r squared. Pi is an already existing variable in R, so I could just come to R and type in pi, and I get 3.14. So pi is available to us already. It doesn't have to be defined. And that's why over here you simply have area equals pi times r squared. And I'll do this too, just to keep us at a nice slow pace at the beginning, warm us up on a Monday. So here we are. I'm coming over. I'm coming to this area. There's no source file yet, so I'm going to hit Command-Shift-Enter or Command-Shift-N or Control-Shift-N, and that creates a new source file. I'll paste our code. I'll put my mouse right there, and I'll hit Command-Enter. That'll run the entire chunk. If I put my mouse here and I put Command-Enter, it will just run this line. But if I put the cursor here and hit Command-Enter, it's going to know that there must be stuff after this bracket, so it will infer the amount of lines to run in order to have a complete statement. So there we are. We have our function, and then we can calculate the area. Calc area. Also, notice this, just lots of little practical tips and tricks. So I could type in calc, and then I could ignore the underscore. I could start typing area, and the autocomplete will still offer me area. So usually what I do is I don't bother typing underscores. I just keep on typing and let the autocomplete offer it to me. Then I hit tab to use the autocomplete, and I'll have a radius of 10. I guess that should give me 31. That's 30, oh, 314. I was off. Okay. So anyway, so there's our area function. Other fun things while I'm here, also taking it nice and slowly. I promise I'll speed up, but just letting everybody warm up, myself included. Another fun thing you could do is you can actually use breakpoints to walk through code. So you have to source a file first, meaning that it is saved as an object in R. So I will save this as demo function. So now that's saved. I will source my file. So I'm coming up here, I'm hitting source. And now that that's ready to go, I can put breakpoints. And now I'm thinking, okay, there's this function. I didn't write it. Someone gave me this code. They said, hey, I got this cool thing. It'll tell you how much area is in a circle, and check it out. So I think, okay. And I don't know my pi r squared derivation. So I come over here, I run the function, so calc area 10, but now I've got my breakpoint. This is great because I can look through. So my environment is only has variables corresponding to this area. So far, I only have the variable r defined because r is what was passed. There's no other variables that are available. So I've got r, and then I can hit F10. For those of you that are on laptops, I guess you're all on that. Don't forget that sometimes you have to hit the function key, the function on your bottom left, in order to, along with F10, in order to actually make the function key be a function. So I hit F10, and it ran that line. I could also use the pictures, so you just basically hit next up here. And now the variable area should be defined, so I can see it. I could type in area and then see its value. And then I could step again, and since this is a short function, we are out of it. So this is a great way to learn other people's code. And when you are coding yourself, if you're with a team of people, you may also want to be thoughtful, imaginative of what it would be like to be from the user's perspective, not the user, but from your fellow programmer's perspective, what their experience will be stepping through your code to learn what you've done. Okay. So we drilled into this nice example. Note that you could also, you didn't necessarily have to hit return. You could put them together into return pi times r squared. You didn't have to make that little area variable in between. Maybe you would choose to do that because you're imagining that someone else is stepping through your code, like I was just saying, and how nice would it be for them to go, okay, that's my area. And then if you're doing other stuff, like you're calculating the volume of a cylinder, then you would take your area, multiply by height, and so on and so forth. So functions can, of course, have multiple arguments, multiple parameters. You can pass vectors, whatever functions, whatever R base functions are naturally vectorized will be vectorized when you pass your function to them. So here is an example. I'll talk this. Oh wait, actually no, you talk. So somebody please take a moment and talk me through this function if you like. Give me a description. Take your time. Yes, thank you.
So you're creating a blanket SQ calc, takes two parameters, x and type, and you're saying if the type is a sample, you're taking the standard deviation of the sample, so not the full population, so it's n-1 in the denominator, but if it's population, you're taking n in the denominator, so it's the population standard deviation, and you're returning whichever one calculates.
Awesome, thank you. So we have just a nice function. It has two parameters, x, the data, and type, the type of calculation you're going to do. So you're going to get some data x. You're going to say, all right, the length of that data is n, so now you have n available to you. Since these are just small little things at the top, you'll use the semicolon to keep it all on the top line. That's a choice. I tend not to do that, but you can do that. Just dump little things at the top. So you're going to define mu as your mean. And then you'll use your type, you'll make use of your type parameter to decide what type of calculation you do. If your type is of type sample, you'll do this calculation. And if it's of type population, you'll do the other type of calculation. And the type is something in statistics we'll talk about later. And then you'll return your output, which will be the standard deviation. So that's a demonstration of how what you pass can control what you do and become control statements inside the actual function. So you can define variables in the body of a function, and they are local. So as you saw, as we were stepping through that variable area, when we were stepping through, it only existed inside of the function. It won't exist outside of it. However, what R will do is if you just use a variable inside a function that wasn't defined in it, R will look outside of the function. Now this is a little bit messy, so you could think of this as a good thing or a bad thing. The benefits of this, the good of this is that you can just make a function which does stuff, and you don't have to pass everything that's in your environment to it. So I have objects, I have just objects in my workspace, whatever, and I want to add them all up. And so inside my function, I say let's say I have the people's accounts. I have Alan, Bob, and Charlie, and I have their accounts, and I say I want to add Alan, Bob, and Charlie, and I do it inside a function. But I don't pass Alan, Bob, and Charlie to the function. I just do inside the function Alan plus Bob plus Charlie. The function will look into the global environment and grab the values for Alan, Bob, and Charlie. That's nice and convenient. You can do quick and sloppy code. The consequence is this is sloppy, and it's not encapsulating your data. So if you mistakenly wrote Charlie, but you meant to write Chuck, if there's a Charlie in your workspace, it's going to be grabbed. So that's just a little detail. In R, you can always give the arguments to a function by using their names instead of their positions. So note that we've seen this before. So in this case, as the creator of the function, when you created x is equal to 1 through 10 and type equal to sample, when you actually passed to the function, you could define type and x. So you can, coming back here, so the first time that I called the function, where's an example of me actually, so I did calc area 10, but of course I can also just do r equal to 10. So just straightforward, it's nice, it's good to your fellow coworkers, I tend to type that way. And I think this is it, I'm just racing, I want to get us to Dplyr, to our topic of the day. But I think I've communicated the heart of what a function is, and then just playing around with some practice problems will do the rest of the work for you. Okay, yeah. So this is good. This is a good stopping point for the rest. The other part, the next subchapter is on data manipulation, but that's our entire topic today. So we will learn our data manipulation with Dplyr. Yes. Oh, sure. So just a question about the R Studio console. So if I want to break my source code into sections, I can come up here and write, area function, and then I type in my 4 brackets, and it becomes a little area, and then I could have, let's say I was doing more work, and I would have a volume function over here. And then if I do Command-Shift-0, Command-Shift-O, not 0, Command-Shift-O, or Command-O, then this little table of contents opens up, and these areas themselves automatically become folding areas. So when I click this triangle, I can collapse and expand that area. Sure. Okay, so moving on to today's topic. Manipulating data with Dplyr. So I'm going to say something, I promise I won't always be saying this, but I will say this today, and I might say this tomorrow. Not all of the material is conceptual. Some of it is just brute memorization of simple stuff, so you can keep your hammers and screwdrivers available to you. So this is just practicing with hammers and screwdrivers. It's not necessarily high level conceptual, but you're going to want to do the work of getting into your head. So use this as a drill session. And part of that drill session actually is remembering the commands you can do, which are filter, select, arrange, mutate, summarize. That can be the friend in your back, the chant in the back of your head. Filter, select, arrange, mutate, summarize. Filter, select, arrange, mutate, summarize. Those are going to be, that's the portfolio of things you could do with Dplyr, and we're going to take those slowly, step by step. So here they are. Here they are laid out: filter, select, arrange, mutate, and summarize. And then after we go through these parts of Dplyr, we'll look at merging data sets, doing basic database operations. And then we'll look at aggregate operations to summarize your data. That's today's agenda. So far, we've looked at some basic data structures. We've seen the ideas of vectors and lists and compound data sets, so basically multidimensional arrays. And now we're arriving at manipulating the data, and we're coming to Dplyr, which is a package which does this for us. And a brief summary. When you filter, you're going to have a nice table of data. You have rows and you have columns. Your rows traditionally will represent your observations, observation 1, 2, 3, and each column is a different field or a different dimension. If you're talking about statistics, you'd say they're dimensions. In machine learning, you would call them features, and in database language, you would call them fields. And then in databases, you would call your rows records, and just in terms of mechanical set, we would call them rows, and if you're a statistician, you call them observations. But that's our platform. We've got a nice table. We've got rows by columns. Rows are our observations. Columns are our features. Now, when you want to get stuff from this data, which is your data, you want to figure out all the rows which are after the year 2005. Well, you're then filtering. You're then filtering your rows for the rows which correspond to the year being greater than 2005. If you only want the column, if you only want to find people's bank account values in those years greater than 2005, then you are selecting the column that represents bank account value. So you filter your rows and you select columns. You filter for what you want to look through, sifting through your data, and you select the fields or values that you care about. So filtering is on rows, selecting is on columns. Cool, and then we'll get to the other two topics, joins and group-wise operations later. So here we are once again, slide 4. This will have the big list, and at risk of being overbearing, filter. You'll be taking your subset of rows, select. You'll be looking for the columns you wish to select. Arrange is just sorting operations. If you remember the last class, we showed the funny little low-level work that was involved in sorting. You would use the order function and would return the locations in ascending order of the data, and then you would use those locations to index a data set, and that's how you would create a sort. Now that's a lot. That's even a lot of words. But in contrast to all that, this grammar of data simply gives you the function arrange, and there you are. You can just arrange, as simple as that, and that will sort the data for you. So you have sorting. You have mutate, which simply returns the set of columns you wish to select. So if I have information about people, and I want to, from everything that there is to know about them, where they went to high school, where they went to college, their age, number of siblings. If I only want to know the number of siblings and their current age, then I can create a data set. I can mutate a data set which only returns siblings and age. And I can take a function of it. I could double their age, and that would be mutating it. So if I return age times 2, not that there's a good reason to do that, that would be a mutation of the original data set. Then, having played all these games with my data set, when I'm ready to get some information from it, I will use summarize. But before summarizing it, this is the order will be better, I need to group it by the chunks I want to summarize by. So I could group it by year. So I could take all of the bank accounts for everybody and see how much money everybody had on every year. So I just group it by year and the different people. So there's lots and lots of rows, lots of rows about people. And there's Alan, Bob, Charlie, Dave, Ed, Fred. For 2000, Alan, Bob, Charlie, Dave, Ed, Fred for 2001. For 2002, for 2003. If I want to collapse that and just get their total every year, I can group by year, and then after that I could take the sum of this group by data set, and that would be summarizing. So I could pass my group by work to summarize. We'll see this all more slowly. I'm just warming you up to what's coming. And then once again, the joins will be the database work at the end of it. So this slide 4 will have a summary. This can ground you in all the tools in our toolbox. Okay, so we've got a sample data set you can play with. It's called births.csv. So if you haven't done so already, you're welcome to load it into your environment. I'll do the same thing. So there we are. I have simply used read CSV. I've kept any text values. So the field sex should actually be the character boy rather than the factor boy. And for yourself, you can display, rows 1 and 2 and columns 131 and 132. That should give you a little 2x2 matrix. And in the next slide, we use the head command in order to return the top 5 values. I'm sorry, the top 5 values, but on a different data set. So we could also load up baby names, so B names. And so having loaded those two up, you could see a couple of things. You could see that we have one data set on births and another data set on baby names. So we have the number of births by year, and then we have baby names also by year and by gender. So they're both by year and gender. In additional fields we have in the baby names columns is the names and something called soundex, which is a way of encoding the way the name sounds. And you could look up on Wikipedia if you're curious about the details of soundex. But for us, that's just going to be a data field. So off the top of your heads, just to make friends with the data, can you guys think of any ways in which these two sets relate to each other and something that could be inferred from them? Yeah, across the year. And can you be more granular about it? Yes. So you can merge these two by year and sex, and then the information there, basically the births column, will be showing up here. And then what could you do? Just think about the data, real world thinking. Yeah, once you've got the number and you got the proportion, you can just multiply the proportion by the total to get an actual number value each year. And so we'll be doing that to practice. That sounds good. Say again?
To make sure that it sums to 1, or is at least close. You can sum by year and sex. For a given year and a given sex, you can sum the top column and see if you get 1.
Right, across.
Then you don't want to be doing that kind of stuff.
I see. Right, then you couldn't multiply the total. Good thinking. So in order to be rigorous about your data set, to be confident that your data set is thinking in terms of a whole, you can add up all the proportions to see if they equal to 1 before you then go ahead and multiply them by n to get a number. It would, yeah, it would help me feel more confident about a data set if you know, it represents the entire domain.